Assalamu alaikum everyone. Welcome to another video of Chemistry with Sanit Tasambe. In this video, we're going to look at the structure of ionic compounds. But generally when I talk about the structure of any compound, the structure will be defined in two words. Like I said, for bonding you will use three words. It's either ionic bonding, covalent bonding or metallic bonding. Similarly, for structure you will use two words. Either the structure will be giant or the structure will be simple. For ionic compounds, these ionic compounds have a giant structure. So if I have to define the structure of an ionic compound, I will simply write that ionic compounds, it's a very important statement which I am about to write. Ionic compounds have a giant lattice structure. Now, a lot of students get confused with the word lattice. So don't get confused, because a lattice just means regular arrangement of atoms, molecules, ions. Regular arrangement of any atoms, molecules or ions is known as lattice. And since ionic compounds have ions, we will say ionic compounds have a giant lattice structure comprising of a regular arrangement of alternating positive and negative ions. If I show you the diagram of an ionic compound, let's say for example NaCl, this is the lattice structure of the ionic compound. It's a giant structure and it contains ionic bonding, and it's a lattice structure. Why? Because it's an alternating regular arrangement of positive and negative ions. So sodium ion chloride, sodium chloride, sodium chloride, so on and so on. This is just a section of the structure I've made. It's a whole structure in a continuous lattice structure. It's a continuous lattice structure, right? So ionic compounds again have a giant ionic lattice comprising of regular arrangement of alternating positive and negative ions. And ionic bonding will always happen between metals and non-metals. However, when we talk about the properties of ionic compounds, when we will be talking about the properties of ionic compounds based on its structure, you can see that since it's a giant structure, so let's talk about the properties of ionic compounds. Properties. Since it's a giant structure, of course, if I'm trying to melt this structure, it will be very hard for me and I have to put a lot of heat, a high amount of energy, right? So hence, since it's a giant ionic structure containing of strong electrostatic attraction between oppositely charged ions, hence ionic compounds will have high melting and boiling point. Ionic compounds have high melting and boiling points. They can ask you the justification behind why ionic compounds have high melting and boiling points. So you can simply write they have high melting and boiling points because they have a giant ionic lattice. They have a giant ionic lattice containing strong electrostatic attractions. Between oppositely charged ions. And high amounts of energy. Is required to overcome them. This is how you justify this property. That they have a giant ionic lattice. First you mention the structure, it's giant. Then you say, what does this giant ionic lattice comprise of? Strong electrostatic attractions between oppositely charged ions. And what's the consequence of that? You need high amount of energy to overcome them. Another very important property of ionic compounds is electrical conductivity. Ionic compounds will not conduct electricity in their solid state. So let's talk about electrical conductivity. For electrical conductivity, we need to see two things. The structure or the compound should either have free moving ions, or the structure or compound should have free moving electrons. Free moving ions or free moving electrons. Ionic compounds obviously do not have free moving electrons, and they also do not have free moving ions. Hence, ionic compounds cannot conduct electricity in their solid state. Cannot conduct electricity in their solid state. Why can they not conduct electricity in their solid state? Because they don't have any free moving ions or electrons. However, a very important point over here is that, however, ionic compounds can conduct electricity. Can conduct electricity in their molten means melted, liquid form. If I melt an ionic compound from solid to liquid, can conduct electricity in their molten state or aqueous state. What do I mean by aqueous state? Aqueous state means dissolved in water. Aqueous state means dissolved in water. And why can they conduct electricity in their molten or aqueous state? Because the ions now are free to move. Because the ions are free to move and can carry charge. And can carry the charge. So if you look at the structure in the solid form, these ions are held together in their fixed positions like that in a solid. So they are not able to move. They're only vibrating about their fixed positions. However, if I melt them, I will weaken these electrostatic attractions between oppositely charged ions. When I weaken these electrostatic attraction between oppositely charged ions, these ions will now be free to move as in a liquid where the ions or atoms or molecules are free to move and slide over each other. And since they are free to move in their molten state and aqueous state. Aqueous state again means dissolved in water. That's why ionic compounds can conduct electricity in their aqueous state or molten state. So aqueous state means dissolved in water. Dissolved in water. Again, in one of the previous videos, we have seen examples of ammonium chloride, which is a solid. It's an ionic solid, ammonium chloride, containing ammonium cation, which is a compound ion, and a chloride anion. And this is a special type of substance because when I heat it, it just directly sublimes into ammonium chloride gas. So ionic compounds are very important from exam perspective. Their dot and cross diagrams, their structure, how to draw their structure, their properties are very important, and you have to go over them before attempting any past paper questions. This is it about this video. In the next video, we're going to start covalent bonding. Till then, thank you very much, everyone.